Hello, everyone. Welcome to this lecture of computer system security. Today, we are going to talk about access control. This is the second part of our lecture 4, which we've started 3 weeks ago, and this is the last week for this lecture. We are going to talk about access control, which is somehow a complementary for authentication for making our system secure. Okay, let's get started by reviewing some of the kind of standard definition for access control. NIST defines access control as this. They say access control is the process of granting or denying a specific request. So it is about granting or denying requests to obtain and use information and related information processing services. So it's about accessing or granting access to some information or information related processes or services. Or it might be even for entering a specific physical facility. So this is called access control. I agree with you if you argue and say that it's similar to what we have said for authentication. We also, for authentication, we said that we want to grant access to some users to into some system. It might be information system, and they may want to use some functions or some services. Yeah, I agree with you. Per this definition, is a little bit probably confusing, but of course, in this lecture, in this very first kind of video of this week, the current video, I'll be making it clear, and I'll show you how authentication and access control, how they sit next to each other, and how they complement, how they kind of work like complementary components in order to increase the security level of our computer systems. The second definition I'm gonna show you is a definition from RFC 4949 that defines access control as a process by which use of system resources is regulated according to a security policy uh, and is kind of permitted only by authorized entities. That here entities, when we say entities, we are talking about users, program, processes, or even devices that are working based kind of on behalf of a user or getting access on behalf of this user according to the policy. So this is a definition. This might be a little bit more clear, but still, I guess there is a need for making it clear what's the relation between the access control and authentication. Okay, here I'm trying to do that clarification on this slide, and I kind of titled this slide as from authentication to access control, because the way it works, and I'm going to show you and I'm going to discuss it here, we'll see that the way it works, we start from authentication in our computer systems. If we want to make them secure, we start with authentication. We authenticate users, and yeah, we start with authentication, and we verify that the user or the client, which is kind of referred to us for getting some resources or getting some functions or getting some accesses, we verify that that user is legit, is what they are saying. They're, for example, I'm connecting to some server and I'm claiming that this is Ahmad Patugi, and that server needs to somehow authenticate me, which means that the server want to make sure that, yeah, this is Ahmad Patugi. This is not someone else pretending or impersonating Ahmad Patugi. So this is a role or duty of authentication, that we verify the legit user, and we call them authentic users. And then there is another step or another kind of thing that kind of happens. We haven't talked about it so far. I haven't even used that term. This is the first time I'm using the term authorization, but because of kind of giving you a full picture, I'm going to also talk about authorization. So let's suppose that we have a system here like this system here, and there are multiple resources on that system. We can for now assume that we are talking about a local system. It's not over the network or internet. We have files, we have let's say disk, we have some other files, we have memory, we have CPU. These are all resources that we have in our system available. And multiple users, they are allowed to use that system. We have multiple authentic users. The users come, the very first filter user needs to pass, or the very first door users need to open, is to pass through the authentication. Of course, there are some authentication mechanism based on what we have kind of discussed. It might be based on password, it might be based on some token, it might be based on some biometric characteristics, whatever it is. We authenticate the user and we make sure, right, this is, for example, Ahmad Patugi, and this is a person who is claiming he is, and we let the person go through. Authorization says, okay, we have multiple users on this system. Of course, not all the users should have the same level of accesses to the resources we have. For example, let's say this is a user, Alice or whoever, and for Alice, we want to let Alice to, this is based on the type of enrollment or subscription that Alice has bought or Alice has with us. We want to let Alice to access to this folder, to this, let's say, JPEG file, and to this space on the disk. But other resources are not, shouldn't be available to Alice. So this is kind of here the meaning of authorization. So we want to let Alice to use some of our resources, of course, not all of them. And even for some of them, for example, this JPEG file, Alice is only supposed to be able to read this file. But then this folder, we want to let Alice to even read and write, on this folder or generate something. So this is the meaning of authorization. It gives certain level of accesses to an authentic user or authentic client. Of course, we have multiple, like I said, resources, and we may have multiple users as well. Bob might be also here, and Bob has a different level of accesses or different level of privileges here. This space here is not available for Alice, but it might be available for Bob. So Bob should be able to access this. So the authorization policy or authorization rule or authorization regulation that we want to implement, of course, might be different per different users that we have. So this is authorization, giving certain level of accesses to a certain authentic user. I'm kind of emphasizing on the term authentic because authorization works only for authentic user or deals only with authentic user. If we have a user not authentic, or if we have a user which is kind of not legit, of course, he or she should be stopped here. He or she cannot pass through or this is the kind of the ideal goal or objective, that we want to filter them here. We don't want to let them come kind of go into or come into the system. So the authorization does not talk about level of accesses for unauthentic users. We are only talking about authentic users. So the first step we take, or the first thing we do, is authentication, and the second thing is authorization, that we define a set of accesses for different users, for different legit users or clients, and then now it comes to the implementation of those accesses. Who wants to make sure that Alice will not have access to this space of to this storage space? Or how we want to make sure that, let's say, Alice only will be able to read from this file, is not allowed to. We defined, we kind of decided for Alice not to be able to write on this file. So who is going to let's say, implement that policy? The policy implementation or policy enforcement is something that happens through access control. So access control, this is a definition we say, enforcing, or let's say access control enforces the given level of authorization among multiple, again, authentic users or authentic clients. We have a couple of authentic users because whoever passed the authentication should be somehow authentic. So, and we have different level of privileges or different level of authorization defined for them. And the access control enforces those authorization decision made by the system administrator. So it's of course, when you have multiple users, more than one users, and multiple resources, the authorization database may kind of increase, may kind of grow, and it's not easy to make sure that the authorization decision made by the administrator will be implemented. That's why we need a separate module called access control, and the access control makes us sure that, or guarantees that the authorization decisions are going to be implemented correctly and full. And another thing we need to consider is about concurrent accesses to the resources. We may have one resources, for example, the JPEG file in our example. We might have decided to let the Alice to read the JPEG file and let the Bob to read and modify the JPEG file. So we have two different kind of level of accesses defined for them, and the access control should somehow make sure that first these two decisions are being implemented correctly, and second, concurrent accesses to that JPEG file are safe and secure, because you are talking about one single resource which might be accessed by more than one user at a time. So Alice and Bob both may go and start working with that JPEG file. So we want to make sure that the JPEG file is safe and their accesses are safe. They can work together on the same resource. And also, in terms of security, we don't want to let this concurrent working kind of end up in having losing some type of security. So these are all kind of duties of access control. Okay, this table somehow summarizes what I've mentioned about differences between access control and authentication, and somehow gives us a kind of clear understanding about how they're different. When we look at different things in this table, first of all, authentication differentiates authentic versus non-authentic client users or devices. This is what we've mentioned. And access control, like I said, it implements or enforces security regulations only on authentic users and clients. Authentication, the output of this is kind of nice observation between or a difference point between the authentication and access control. Authentication's output is a binary decision of yes or no. For every single client that kind of refers to our authentication system in order to get access to our system, the ultimate answer to that user is either yes or no. We let them go, we let them in, or we say no, we reject them. So the answer, the final decision, or the final output of the authentication process is yes or no. While this is not the case for access control, of course, in access control, the output might be many different things and many kind of fuzzy things. It is not digital 0 or 1, yes or no. For example, it might be granting some level of accesses, or it might be reducing the level of accesses, or it might be delaying some clients. For example, two clients are supposed to, both of them they have privilege to access a single file, but one of them has a higher priority and they want to access that file at the same time. What the access control mechanism will be doing is that it gives the permission to one of them and delays the second one, because we don't want to let two processes write on a same file at the same time. This is impossible. They just end up kind of ruining the file. So um, that's why we say access control in some, the output of the access control is kind of very different, and it might be granting different levels, it might be delaying and stuff like that. In terms of again, enrollment or pre-registration, authentication of course needs enrollment and registration of clients or users in order to be able to later check and make sure that, okay, this is an authentic user, but there is no need for enrollment or registration in access control, because here we are talking about all authentic users. And the last thing is about having some type of secret information in authentication. We have some type of secret information in authentication that includes, that might be, for example, password, PIN, or let's say some kind of biometric characteristics. These are all required in order to be able to differentiate authentic users versus unauthentic users. And again, we don't have such thing in access control. What we have in access control is just some simple IDs. We use some IDs in order to be able to differentiate different clients, because like I said, all of them, when it comes to access control, all of them are legit users, and in terms of having no impersonation, or in terms of being legit or real or genuine users, they're all real genuine users, and we just want to be able to differentiate them. So we have Alice and Bob. We don't want to we just simply give them some IDs. Alice is user number 1, Bob is user number 2, and that's it. There is no secret information here. Okay, the next kind of item that we want to talk about is the security requirements that we expect to get from access control. There are some, if you refer to the book, there are a list of something about 20 different security requirements that I've just listed the most important ones here, those that apply to almost all access control systems and mechanisms. So there are two, first of all, there are two basic security requirements which are kind of which come from the definition of access control. The first one says limit the information system access to authorized users, processes, acting on behalf of the authorized user or devices. So of course, when we say access control, the basic expectation we have is to limit the access to the resources that we have in a system to some specific users. This is basic expectation or very primitive expectation that we might have from an access control mechanism. The second is to limit information system access to types of transactions and functions that authorized users are permitted to execute. Again, we don't want to let the user to do whatever is possible in our system. We want to limit their capabilities, what they can do, into some specific transactions or some specific properties that later we'll call them access rights. We want to give them some specific access right, not all available accesses in our system. Again, this is this seems to be a very basic and primitive expectation that one might have from every access control mechanism. But on top of these two, there are a few other security requirements that might be expected from access control mechanisms that I'm going to talk about them. Number three talks about separating the duties of individuals to reduce the risk of uh, concurrent or parallel activities without any collision. I've already talked about this a little bit, and I mentioned that uh, we might have multiple users in our system, of course, and of course, again, we have many resources, and some of these resources uh, might be shared or might be the access to those resources might be shared between multiple users. For example, in a computer system, let's talk about a local computer system. What can you point or give me as an example, which is a resource that we want to give access to multiple users, not only one user? I can point to for example, the CPU of that computer, or memory portion of that computer, or disk of that computer, or the kernel of operating system. These are all resources that we have to, at the end of the day, share them or give access to them to multiple, or let's say all processes or users that we have in our system. So the access control should be able to separate duties of individuals. And this is again for reducing the risk. Number four talks about prevent non-privileged users from executing privileged functions and audit the execution of such functions. In our system, we may have, let's say, let's assume we have two users, two authentic users, Alice and Bob, and they both are allowed to access some properties, of course, different properties, different resources. Some of the resources are privileged. And let's say we have granted some privileged accesses to Bob, but not to Alice. So Alice shouldn't be able to somehow change her privileges and go to the top level of accesses. That shouldn't happen. And if that thing happens, we should be able to detect that. We should be able to detect and take some actions for that. There is a principle here, which is called principle of least privilege. The principle of least privilege says, try to grant privileged accesses, in our case is privileged accesses, at the very least level that you can. You don't need to define many different privileges, and now you have the problem of handling multiple privileges at the same time, and make sure that they work together, and make sure that one of the non-privileged users or accesses can be turned into a privileged one. These are all complexities that would happen once we have multiple privileges. If we don't have any kind of privilege in our system, or use the minimum level of privileges, that would be helping us. The next thing is about use session logs with pattern hiding display to prevent access and viewing of data after a period of inactivity. It says for access control, we may want to use sessions, and sessions, we've talked about sessions before a little bit. Sessions means that you have a user, authentic user, the user has already authenticated, and we know that this user is legit, and the user wants to use a specific resource which we have already granted the access to that resource to the user. But that doesn't mean that the user is allowed to use that resource forever. We have a limited amount of time, let's say multiple, this is for example time, we have multiple let's say time ticks, and the user is only allowed to use that resource for, let's say, 1 second, and the session is defined for 1 second. After that 1 second, either the user or the processes or the process or the device, either it has finished his kind of it's worked with the resource or not, we kind of get that resource back, and the user, if he or she needs to continue working with that resource, needs to start a new session, needs to request for a new access, and we of course grant it, but there are some time considerations. And number 6 says terminate a user session after a defined condition or after a defined period. There might be some situation. Of course, the very first one is time. We don't want to let the user to access our resources forever. In number 6, we just want to give them access for some given amount of time, and after that given amount of time, the access will be kind of disabled. But other than time, we also may consider some other conditions. For example, the user is using, let's say it's a file, and the user is allowed to write on that file, and the time is still not over. That 1 second is still available for the user to write on that file, but we realize that, or the system detects that the user is writing too many things on that file. So we terminate the access right. This another kind of security requirement that we may expect from access control system is monitoring remote kind of sessions or remote accesses, which is of course good for remote users and remote access control. And the last one I have here, number 8, is employing cryptographic mechanisms to protect the confidentiality of remote access sessions. If we want to support remote accesses, of course, there should be mechanisms in order to make sure that the information between the system and the remote users is being transferred securely. And of course, cryptography is a great thing. We can use it, and we can kind of include cryptography in our access control so that the remote users' data or remote users' privileges or accesses are all kept safe. Okay, now I'm going to talk about in general access control policies that we have. We have 4 category or 4 kind of approaches in order to implement access control policies. The first one is called discretionary access control. In a discretionary access control, it controls access based on the identity of the requester and based on some access rules that actually comes from authorization database, and I start kind of stating what requesters are supposed to be able to access and what are not. So basically what it is, it determines or let's say it decides for resources and for the users case by case. We have 5 resources, let's say, and 2 users, Alice and Bob. It says, okay, Alice is able to, or Alice is allowed to access resource number 1, yes or no. Alice is allowed to use resource number 2, yes or no. This is how it works. Of course, we see details here. I'm just giving you a high level description of them, and we'll see their details in the rest of this lecture and our next lecture for this week. So this is what is called discretionary. The second one is role-based access control. In role-based access control, it doesn't work this way because it says the discretionary based kind of methods, they end up requiring a huge amount of memory because you wanna determine the access for every single user, every single resource, which is a big thing. In the role-based, we kind of the access mechanisms, they define some roles, and they control the access to the resources based on the roles. They say, for example, we have 100 users and let's say 200 resources. We define three different roles. Role one is reader, someone who is only allowed to read information. I'm just giving a kind of basic examples. Of course, like I said, we go and see the details of each. Role two is read and modify, users that can read files and can modify them. And role three is read, modify, and delete. And then we assign each of our 100 users to one of these three roles. We say, okay, user one is a reader. User one is being assigned to role one. User two is assigned to role two, and so on. This is how it works. We define some roles, and the users are being assigned to roles, and that way it's going to be easier in terms of control. The third one is mandatory access control. In the mandatory access control, it controls access based on comparing security labels and some security clearances. We have some security labels and some security kind of permissions that we have granted. They are called security clearances. And the name mandatory here comes from the fact that none of the users or none of the requesters, we should make sure, this is basically, I should put it this way, none of the users should be able to change the security label or security clearance of another user or another requester, either by by a legit set of operation or by violating some operation. We should make sure that there is no such way for a user to change the level of accesses for another user. This is called mandatory access control. And the last one that I'm gonna just here quickly give you a high level description of that is called attribute-based access control, which is, I guess, might be easy for you from the name. We define some attributes for the users and resources, and the access control is being done based on those attributes. Okay, in our course, we will be talking about discretionary-based access control, DAC. We'll be talking about role-based and attribute-based access controls. But we don't talk about mandatory-based. Okay, let's also talk about some terminology before getting into the very first one. Yeah, we have some terminology when it comes to access control, and this terminology we will be using them. We have subject. Subject basically is a requester or is the client, the user or process that works on behalf of a user, or a device which is accessing something on behalf of a user. So we call all of them subject. Any entity which is capable of accessing an object. And we have three levels or three classes of subjects. We have owner, we have group, and we have world. Owner means that the subject is the owner of that resource. So of course, the highest level of access should be granted to the owner subject. Group is a group is an set of subjects which are in a group, and they have some levels of access to that. And the world means everybody other than group. And then we have objects. Objects are resources, in fact, in our system, which are we are talking about accessing these resources. So, and resources to these, accesses to these resources are the question that we are talking about now. Yeah, entity, it might be entity that it contains some information, and the information is being received or is being read or is being modified or is being read by some subjects. And then we have access right. Access right describes the way in which a subject may access an object. And of course, there are multiple access rights based on the objects. For example, if the object is a file, let's say, these are uh, different access right that we can list for a file for that object. Read, someone may want to access to that object or to that file to read information. Someone may want to write on that file. Someone may execute that file. But if that's a kind of executable file, someone may want to execute that file. Execution means that that file is being read and is being loaded into the main memory, and the processor now is supposed to execute that. Someone may kind of request for deleting that file, and the file is going to be kind of deleted forever. So that's again another type of access. Someone may want to create a file. Someone may want to search among those files and find a specific file, or search inside that file and find a specific thing. So these are all different access rights that we may define for an object like a file. If we change the object, of course, the access right will be different. For example, if we are talking about a memory as an access, as an object, access right might be different. In memory, we only have read, write, and for example, allocation. You want to allocate a part of memory to a specific process, and that's it. If we are talking about uh, another object, for example, let's say our object is network access. What types of accesses do you may define for that? You can pause the video and think about types of different access right for a network resource. It might be sending information and receiving information. This is, of course, a very high level types of rights that we are defining. We can define it in a lower level. We say establishing a port, an out port, establishing an in port, and we may define it in very different kind of levels of details. So you see that basically what I'm trying to say is that the access right will change based on the uh, resource, based on the kind of object that we have. Okay, now I'm gonna, we have enough kind of preliminary to start talking about the very first access control mechanism, DAC, discretionary access control. In the DAC, access of each subject to each object is determined based on a situation which is stored in a matrix. Like I said, it's a case-by-case access control mechanism. This table shows it kind of very clearly. We have multiple resources or objects. Let's say file number 1, number 2, number 3, and number 4. These are the resources that we have in our system. And we have 3 users, which are our subjects. So user A, user B, and user C. And of course, every user may have some level of accesses or may have some access right to each of these objects. For example, user A is the owner of the file 1. So here in this cell, which kind of sits in the row 1, column 1, we have written own, read, write. So the user A is the owner of file 1, and since since he or she is the owner, user A is able to do whatever he or she wants to do with this file. But when we look at the second cell of the row 1, user A doesn't have any privilege or doesn't have any right with respect to file 2. Basically, file 2 is hidden from user A's point of view. User A never sees, never finds, or never observes file 2 because there is no access defined for uh, user A with respect to file 2. So, like I said, this is of course a case-by-case situation. The system determines access to each object for each subject separately and sees that thing as a separate case and decides about it in a separate thing. And of course, we are talking about computers. When it comes to our machine to do that, we need to implement a matrix like this that you see in this slide. And that matrix kind of stores the information. And that information is basically all access policies or all access regulations that we have uh, kind of that we have defined or we are supposed to follow. Okay, here in DAC access control, we have the situation at which an entity may grant access rights either by permit or by violating some rules to other entities. How it's possible? For example, user A is the owner of the file. User A may share that file, may give a copy of that file. Let's say user B. User B is the owner of file 2, and the user B may read may read file 2 and may share a copy with user A. And that way, user A is basically reading that file. So this might be somehow the violation of the DAC access control. In some situations, we kind of intentionally give that level of flexibility to our users. We say that, okay, you are the owner and you you are supposed to share the file with whoever you like. So user B shares that with user A. But in some cases, we don't want. For example, user C is the that has the access of reading, and the user C also may give a copy of that file to user A, which might be someone that we don't like it. Okay. Now I'm going to talk about the implementation of DAC access control. This matrix that I just showed you here, this is a matrix, like I said, that we may have in discretionary access control. But this matrix is basically when it comes to real systems, when it comes to computers that they have, let's say, how many files do you have in your computer? It might be a million files. How many users do you have? We shouldn't say users, though we should say processes, because even we may want to apply some access control for different processes. Some of the processes, they don't have access to some of the files, but some others they do. So let's say you have a million, or let's say not go that big, 10,000 files, and you have, let's say, 1,000 processes or 100 processes. So if you want to really implement it like a matrix like this, it's gonna be a matrix of 100 rows by 10,000 columns, which is a super big matrix. Even if we assume that uh, we put either 0 or 1 in each of these cells, it's gonna be a super big access control file, which is of course is something counterproductive. That file slows down the system. That file might be the place of attack itself, and many other issues we may have with that file. So because of these reasons, when it comes to the implementation of discretionary access control, it's rarely being implemented as a matrix. There are multiple ways. One, I'm going to talk about it here. we may implement a DAC access control using a linked list. Here we are putting it this way. We say, okay, file one is one of our objects, and this file one is supposed to be accessed by user A with the privileges or access right of own read write. Also, user B here is a linked list. The first user points to the second, or the first data structure points to the second data structure. For those of you that might not be aware or may not remember what is a linked list, you can assume it's something like an array. It's an array, but the length of that array may vary. Here we have an array of 3 elements. Here we have an array of 2 elements. Here we have an array of 4 elements. We can add or drop elements into this array at the end of the array or everywhere. Let's say, okay, file one is one of our objects. User A is one of the subjects. These are the access rights of this user. And then through this pointer, we go to the next user. User B has this access to this file, and then the next user is user C, who has this level of accesses to this file. And now we go to the second file. Second file is file number 2, and file number 2 should be, look at here. This is a kind of representation of the same table. File number 2 should be accessed by user B. User B is the owner, and then user C. That's it. There is no one else, so the list ends here. So here you see we have listed them based on the objects that we have. This way it is called kind of implementation of the access control mechanism, or DAC, based on access control list. Another way is to kind of organize it based on the users. So we have user A. In fact, here in the left kind of side, we see the implementation of the matrix by decoupling the columns. Every column now is being stored as a list, and each list refers to one object, file 1, file 2, and so on. But we can do it, we can separate the matrix based on rows, and each row now refers to one user. And these are all accesses or all rights that user A has. User A is allowed to use file 1 with these levels of accesses, with these rights. And he or she, user A, also is permitted to use file 3 as owner. File 1, file 3 as owner. And there is no, this kind of blank cell does not reflect here. We don't use any space for that. User B, we have all of these, we put them together, we link them to each other, and we generate that linked list. And user C, we generate the linked list for the user C as well. Okay, let's go forward. The second implementation for DAC access control is through some tables. We can save the matrix like a table like this. If we wanted to store it as a matrix in a matrix format, we had to store n times m different entries. N is the number of objects, and m is the number of subjects. But here we are implementing in a table format. Basically, the table says wherever in this matrix you have a cell which is not empty, you need to have a row for that specific cell. That's it. Like I said, again, I'm kind of restating this because this is important. In this example case that you see, we have only 1, 2, 3 kind of empty cells. because this is a kind of very simple example. But if you assume about a system that has 100 processes versus 1,000 or 10,000 files, many of the cells of that matrix will be empty. That we call it a sparse matrix. It mean, which probably you have heard about the sparse matrix, means a matrix that many of its cells are empty. And of course, we don't want to use memory. We don't want to pay to store that matrix that most of its cells are zero. We don't do that. We of course do a different one. The first way is to implement it as a linked list. The second approach is to implement it as a table that again might be sorted based on subject or based on object. It's up to us. Here, it's sorted based on subjects. You see that the table, you first see the first subject, subject A, user A, and then subject B, and then subject C. We can store it based on, we can sort it based on objects, file 1, and then file 2, and then file 3 and file 4. This is another type of storing our access matrix in a DAC access control. And the last method that I'm going to talk about in this video is called implementation through protection domain. What is a protection domain? It says basically we somehow generalize the idea. We say that a protection domain is defined as a set of objects together with the same access right. So this should be subject. A set of subject. That's okay. A set of objects together with the access right related or associated to that object. So we say file 1 and file 2, they go to a specific protection domain, and file 1 and file 2 are only readable. This is one protection domain. And user A and user 2 later will be associated to this protection domain. When we say user A and user B are assigned to protection domain 1, it basically by itself means that user A and user 2 has only access to file 1 and file 4, and that's going to be only reading those files, because that's the access rights defined for that protection domain. And of course, it's clear that it's a kind of extension of this idea. You don't want to put a row for each specific subject and each specific object. No, you couple the objects together. You say file 1 and file 3. This is one protection domain, and with the access right of only reading, whoever needs file 1 and file 3 with these levels of access will be later assigned to that protection domain. And of course, it's something that makes it easier, and it's being used in some of our real systems. And users are being assigned to the protection domain, like I said. And association between the users or processes, or let's say subjects and protection domains, might be static or dynamic. Means that you assign a subject to a protection domain, but later you decide to change the access right of that subject to that object. So you assign that subject to a different protection domain, and it works. Okay, please use protection with the same spelling for today's attendance code. And I think that should be enough for today. We continue for the next recording. We'll talk about the 2 other access control mechanisms, and we'll see how they work. Thank you for attending this class, and have a good day.